Hey guys, these are going to be our notes about calculating logarithms. All right, so this is going to be on slides 6 and 7 of your notes on your digital notebook today. So slides 6 and 7. At the top, you can go ahead and put your title, Notes Calculating Logarithms. We're going to start with evaluating using the loop trick. So when you have a problem that says log base b of a, really the question that you're asking yourself is b to what power is a? So we're going to look at a couple of little examples of solving it in this method. So it says log base 3 of 9. So basically when you do your loop trick, okay, we're trying to figure out what this is equal to. When you're doing your loop trick, you're basically saying 3 to some power is equal to 9. So you're asking yourself, this question right here is 3 to what power is 9? What power would we raise 3 to get the answer of 9? Hopefully we know that off the top of our head that 3 squared is 9, so x is just equal to 2. So we wouldn't really say x is equal to 2, we would just say log base 3 of 9, that's equal to 2. That would just be our answer, would be 2. There was no x originally in the problem, we were just evaluating, we're calculating the log. So again, we have another problem just like it, log base 2 of 32. So the question you're asking yourself is 2 to what power is 32? So you might get a calculator out or something. Hopefully some of the 2's, we know those ones, but 2 to the power of 5 is 32. So that means that log base 2 of 32 is just equal to 5. We're just calculating what it's equal to. If we did the loop trick, like what would it be equal to? All right. Well, not every problem we're going to be able to do this for, because not every problem is going to have an exponent or a power that's just going to be a nice even number. So we're going to talk about using a calculator to evaluate our logs. One thing that we need to know is that when we're looking at our calculators, whether you're using like a TI-83 or a TI-36 Plus, or even your Casio, your iPhone turned sideways, there's always only 2 log buttons. Ran out of room. But the 2 log buttons are log, which is common log, log base 10, and natural log, which is log base E. We just don't write it. So there's 2 calculator buttons that you're going to have. So we're going to use those calculator buttons real quick for our examples. We have log of 17 and natural log of 8. So remember, the question that you're asking yourself here is 10 to what power is 17? E to what power is 8? And we don't know those things, right? So that's why we're going to use our calculator. So in our calculator, I'm going to use Desmos. You can use your iPhone turned sideways. You can use your Casio, whatever you have. You can use Desmos. There's a couple different ways you can do it. You can go to like the typing, and you can literally just type in the word log and then do log of 17 that way. Or you can do this functions button over here and go to miscellaneous. It's like the last one over here, miscellaneous, and then there's a log button down near the bottom. So they give you the same answer, 1.203.230.4489. We'll just do 3 places after the decimal. I didn't specify, but it'd be 1.230. 1.230. And then if I wanted natural log of 8, remember we don't know e to what power is 8, so we're just going to go do our natural log button. And again, you can either just use like the typing and type in ln and then do the number 8, or you can go to functions, go to miscellaneous, and then logs on the third one from the bottom on the left, and put in your 8, and they give you the same thing. So if you do 3 places after the decimal, it'd be 2.079. 2.079. All right, well, not every problem, though, is going to be log or natural log. Not all of our problems are going to be natural log or common log. There's different bases that we can have. So we have something called the change of base formula that's going to help us use our calculators. The change of base formula is log base b of a. You can change it to whatever base you want. You can change it to any base, but you're definitely going to either change it to log or natural log. You're never going to change it to something else unless they like gave you some other answers. But if you want to use your calculator, you're going to change it to log or natural log. So how it works, you do change of base, you put log over log. The number that was once your base is now going to be a regular size number on the bottom. And the number you had of a, that number is going to still be normal size, and it's just going to go on the top. So I'm going to show you guys some examples, and we'll use our calculator. So examples, log base 6 of 49. We can't do what we did earlier. Remember, it was like 6 to what power is 49? Because we don't know that off the top of our head. And we, even if we estimated it, we probably wouldn't get our exact number. So instead, we use our calculator, okay? We can't do log base 6 of 49. 6 to what power is 49? We don't know that, okay? So what we're going to do instead is our change of base formula. How it works is you do log over log. The base number 6 goes in the bottom. It's now normal size. The 49 goes on top. And we're just going to use our calculator now that we've changed the base. There's no log base 6 on your iPhone or your Casio or whatever it is. So we're going to do log base 40 or log 49. That's log base 10. So it's just regular common log. So log 49 divided by log of 6. So I'll do my log 49 divided by log of 6. I get 2.172, so it just ends there, 2.172. And that's just my answer. So again, this wasn't one we could do like off the top of our head. We needed our calculator. We didn't have a log base 6, so we had to do change of base. So our next example says log base 12 of 3. Well, we don't know 12 to what number is equal to 3. We don't know that. So we're going to have to do change of base. So we go log over log. The number that was once the base now goes in the bottom. It's regular size. It's just log 12. And the number that was on the top, or the number that goes on the top, is just whatever like the A part was. So log of 3 divided by log of 12. And we're just going to use our calculator. Log 3 divided by log 12. So log 3 divided by log 12. So I get 0.44211. We're just going to do 3 places, 0.442. So what that means is that 12 to the power of 0.442, dot, 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 it keeps going on forever, is going to be equal to 3. So we can see that if we, raised 12 to the power of that number, 0.442, that's close to 3. And then if you add in, all your other, we're just going to keep getting closer to 3. So eventually we got it. Okay. All right. This is going to be the front, or the first slide, number 6. This is going to be the first picture you take. So if we can flip your paper over, we're going to do some simple, just little solving log equations today. I think you just have like one of these on your homework. We'll get into like real solving equations later, but you're just going to go ahead and evaluate the log piece. Then solve for x. So our first example says log base 5 of 2 equals x plus 3. So we're going to go ahead and evaluate our log piece. This isn't one we can do in our head because remember it's 5 to what power is 2. We don't know that. So instead we're going to have to go ahead, evaluate the log piece. You might have to do this, the change of base. Add this up here. You might have to do change of base if you can't like evaluate it normal, but the way that you do your change of base is you put log over log. The number that was once the base is now normal size in the bottom. The 5 goes on the bottom and the 2 on the top, equals x plus 3. I'm going to go ahead and evaluate that. I'm going to use my calculator. I keep using Desmos. Log 2 divided by log 5. oops, forgot I divided by. It's not deleting my part. Here we go. So I get 0.43067, so round to 0.431. 0.431. So we get 0.431 equals x plus 3. And then we just solve for x. So I'm going to subtract 3 on both sides. We get x equals -3 plus 0.431, or 0.431 minus 3. So we get -2.569. -2.569. And that's just our solving for x. So this time we do have an x equals because this had an actual equation. All right, our next one says log base 8 of 4 equals 2x minus 3. This is our last little example. So again, we can't evaluate this piece just, you know, off top of our heads because we don't know 8 to what power is 4. That one doesn't work. So we're going to go ahead and do our change of base. So we do log over log. 8 goes on the bottom, 4 goes on the top, equals 2x minus 3. So I'm going to go to my Desmos, log 4 divided by log 8. Log 4, and then I go outside the parentheses, divided by log 8. So I get 0.66 repeating, so it's going to be 0.667 equals 2x minus 3. Then I'm going to go ahead and just solve for x. I'm going to add 3 to both sides. I get 3.667 equals 2x. And then last step would be to just divide both sides by 2. And we get x equals, go to my Desmos, 3.667 divided by 2, 1.8335. 1.8335. And that's our x equals. So in your homework tonight, you're going to have some where you evaluate, you know, just doing the loop trick, this kind of thing. You're going to have some where you just put in your calculator, some where you go ahead and do change of base. And I think you just have like one little solving problem. But these notes can go in on slide, I think it's 6 and 7 if I'm not mistaken. It might look a little bit different because I added some stuff up here. But that's it for your notes.